Hi everyone, let's continue to Chapter 10, Oil Pollution. Oil can be defined as any neutral, non-polar chemical substance that is a viscous liquid at ambient temperatures and is immiscible with water, but soluble in alcohols or ethers. Oil had high carbon and hydrogen content, and are usually flammable and slippery. Oil may be animal, vegetable, or petrochemical in origin, and may be volatile, or non-volatile. Organic oils. This type of oil is produced in remarkable diversity by plants, animals, and other organisms through natural metabolic processes. Lipid is the scientific term for the fatty acids, steroids, and similar chemicals often found in the oils produced by living things. What is petroleum? Petroleum is a naturally occurring flammable liquid, consisting of a complex mixture of hydrocarbons of various molecular weights, and other liquid organic compounds, found in geologic formations, beneath the Earth's surface. Petroleum covers both naturally occurring unprocessed crude oils, and petroleum products that are made up of refined crude oil. This figure shows where other petroleum and natural gas located beneath the Earth. Normally, petroleum is extracted using a drilling rig. A fossil fuel, it is formed when large quantities of dead organisms, usually zooplankton and algae, are buried underneath sedimentary rock, and undergo intense heat and pressure. This process takes million years to create it. Fossil fuel is not only extracted from the ocean bed, but also on land. Normally, this phenomenon occurs at Arabian countries. Crude oil is a naturally occurring mixture consisting mainly of hydrocarbon, and trace amounts of sulfur, nitrogen, or oxygen derivatives of hydrocarbon. It can be extracted from the earth as a liquid form with some amount of gas forms. The trace amount of inorganic matter in crude oil mainly, nickel and vanadium. The density of crude is around 0.79 to 0.95 grams per centimeter cube, under the surface condition. This pie chart shows the elemental composition in percentage ranges for crude oil that extracted. Mainly consist of carbon, 80%, followed by hydrogen, 12 to 24%. That is why the chemical formula for petroleum is C&H. This figure shows the product made from a barrel of crude oil, mostly for gasoline and diesel. Crude petroleum is a highly complex mixture of compounds chemically composed of hydrogen and carbon, called hydrocarbon. Hydrocarbon is any chemical compound that consists only of carbon and hydrogen. For example, methane, CH4, ethane, C2H6, propane, C3H8. There are three principal types of hydrocarbons. The first one is aliphatic hydrocarbons. This hydrocarbon is normal, branched and cyclic saturated. The second is aromatic hydrocarbons, which have at least one aromatic ring. And the last one is asphaltenes, which consist primarily of carbon, hydrogen, nitrogen, oxygen, and sulfur. Oil spill can be defined as a release of a liquid petroleum hydrocarbon into the environment, especially marine areas, due to human activity, and is a form of pollution. The term is usually applied to marine oil spills, where oil is released into the ocean or coastal waters, but spills may also occur on land. Although only a small percentage of oil enters the ocean from major oil spills, the extreme toxicity oil has on marine animals is our concern. A smaller spill at the wrong time or wrong season, and in a sensitive environment may prove much more harmful than a larger spill at another time of the year, in another or even the same environment. Let's look for example. In 1976, a spill estimated to have been less than 10 tons, killed more than 60,000 long-tailed ducks wintering in the Baltic Sea, and attracted to the seemingly calm water surface created by the oil slick. This could be compared to the effects on seabirds in Alaskan waters, from the approximately 40,000 tons of the larger Exxon Valdez oil spill in 1989, when an estimated 250,000 birds died. Fate of oil in water. After one oil spill incident, the seawater surface will undergo physical, chemical, biological, and microbiological alternation. The physical factors have the most significant initial effect upon immediate oil discharge. The oil will undergo weathering process, spreading and movement with the water current. 60% influenced by currents, 24% by wind, 16% by others. Evaporation of volatile hydrocarbon. In less than half an hour, all the volatile hydrocarbon will disappear. In less than half a day, 50% of the carbon-12 to carbon-14 disappeared. Dissolution. The lower the molecular weight of hydrocarbon, the greater is the polarity and solubility. Emulsification. Emulsification will create chocolate mousse in the marine environment. It is a dissolution and chemical alternation process. This chocolate mousse contains suspended particles, sands, heavy metals, adsorption, biodegradation process. When this chocolate mousse reaches the land, or beach, it can easily to identify through tar balls. These figures show the tar ball that normally can be found in a beach area. They may come in different sizes and shapes. The next one is sedimentation. Oil can be deposited onto particulate sediment, and settle to the sea floor. Oil can also adsorb on the detritus, and go through food chains. Next is microbial degradation. This process involves bacterial activities, where they will break down a hydrocarbon chain into CO2 and H2O. Oxidation. Photochemical oxidation produces a more soluble and toxic compound. This figure summarized what happened to the oil once the spill in the marine environment. Combination of physical, biological and chemical processes. Besides that, the oil may also be consumed by marine organisms, such as fish and shellfish. Once they enter the food chain, the oil will move to higher trophic, and lastly to humans. What are the sources of oil pollution in our aquatic environment? Although the major source of marine oil pollution might appear to be accidental oil spills, but tanker accidents only account for less than 7% of the oil discharged into the ocean. Nearly 43% of oil discharged into the marine environment enters the oceans via urban storm drainage systems and industrial discharges. For example, oil spills and leaks during car maintenance, and illegal discharge and dumping of waste oil. The graph shows how many millions of gallons of oil each source puts into the oceans worldwide each year. Do you notice that down the drain is the most significant? The oil spill only accounted 37 million. Municipal and industries waste. Almost all domestic waste contain oils and greases. During rains, iridescence caused by oil and petrol can be seen on the roads. Spill oil from the garage may wash into the drains, and lastly will reach the sea. Tanker ship operation. The segregated ballast water is carried in separate compartments and might contain oil. At the loading terminal, the cargo is loaded on top of the oil in the slop tank. Dry docking. All ships require periodic dry docking for servicing repairs, and cleaning. Ship repair yards should provide slop reception facilities. Marine terminal. Accidents through human error and pipeline failure during loading and discharging oil at terminal. Care taken to minimize accident. Build and fuel oils. Ballast water system. When pumped overboard it carries oil into the sea. In addition, all shipping needs to pump out bilge water which contains oil from the ship's engine. Tanker ship accidents. Non-tanker ship accidents. Cargo ships, fuel oil lost to the sea. Offshore oil production. Oil extracted from seabed contains some water, must be extracted on the platform before transported to the refinery. Drilling oil well. Oil-based mud is separate from drill cuttings, dumped on the seabed beneath platform. Blowouts are the uncontrolled release of oil from the well, need great precaution. Atmosphere input. Incomplete combustion of petrol or diesel in motor vehicles and gas flared off at oil platforms, washed out in rain. License dumping. Shipping channels in estuaries and ports need regular dredging. The dredging spoil which is usually dumped at sea is contaminated with oil. Natural input. Natural sources, oil deposits close to the Earth's surface seep out. Example, Kampung Minyak, Kudat, Sabak. 3 outlets of the oil seepages at Kampung Minyak aligned in straight line indicating a fault-controlled structure. What are the oil spill impact? Damage, toxicity caused by oil on marine environment. Tar balls deposited on beach. Deposition on benthic fauna, corals, mangrove, seagrasses. Tainting of fish. Killing larvae, adult organisms, seabirds, and other organisms. Accumulated in organisms through food chains, causing cancer to human through eating the oil-contaminated seafood. Aromatic hydrocarbons are more toxic than aliphatic hydrocarbons. The 96 hours LC50 is between 10 to 30 parts per million. The thick, sticky oil coats the feathers on birds, inhibiting flight, and the ability of those feathers to insulate the bird. The gills of fish become clogged with oil, and the fish suffocate. Marine mammals' bodies become coated in oil, and they cannot maintain their body temperatures. Oil-coated marine plants cannot obtain energy from the sun for photosynthesis. Oil may also become trapped in sediments for many years, and may become suspended again in storms, or dredging. How can PAHs affect human health? Short-term effects such as eye irritation, vomiting, diarrhea, and confusion. Long-term effects, such as cataracts, kidney and liver damage, and jaundice. Some PAHs are known to be potent carcinogens. Some people have breathed or touched mixtures of PAHs for long periods of time have developed cancer. These PAHs had tested on laboratory animal. Lung cancer from air breathing. Stomach cancer via ingested in food. Skin cancer when applied to skin. Crude oil and refined fuel spills from tanker ship accidents have damaged natural ecosystems in Alaska, the Gulf of Mexico, the Galapagos Islands, France, and many other places. The quantity of oil spilled during accidents has ranged from a few hundred tons to several 100,000 tons. For example, Deepwater Horizon oil spill, Atlantic Empress, Amoco Cadiz. Smaller spills have already proven to have a great impact on ecosystems, such as the remoteness of the site, or the difficulty of an emergency environmental response. Oil spills at sea are generally much more damaging than those on land, since they can spread for hundreds of nautical miles, in a thin oil slick which can cover beaches with a thin coating of oil. This can kill seabirds, mammals, shellfish, and other organisms it coats. Impact of oil on fisheries, such as loss of breeding habitats. accumulation of toxins, poor taste, and impact of sport fishing. Seafood safety with oil chemical. Oil spills can prompt concern about the seafood safety. The bioaccumulation in seafood such as fish or shellfish can occur through food items, water, sediment, or through skin and gills. Polycyclic aromatic hydrocarbons, PAHs, are the chemicals in petroleum-based oils most likely to bioaccumulate in seafood tissues. Different seafood species affected by oil spills. 1. Fish is less likely to be exposed to oil than other marine organisms. This is because the oil floats, and fish usually don't come into contact with oil. 2. Crustacean, such as lobster, crabs which can move away from oil. 3. Mollusks, such as mussel, clams. These organisms are the most affected by oil spills, due to they anchor themselves, and cannot avoid spilled oil. Oil penetrates into the structure of the plumage of birds, and the fur of mammals, reducing its insulating ability, and making them more vulnerable to temperature fluctuations, and much less buoyant in the water. Animals that rely on scent to find their babies, or mothers fade away, due to the strong scent of the oil. This can cause a baby to be rejected, and abandoned, leaving the babies to starve, and eventually die. It can impair a bird's ability to fly, preventing it from foraging, or escaping from predators. As they preen, birds may ingest the oil coating their feathers, irritating the digestive tract, altering liver function, and causing kidney damage. Heavily furred marine mammals exposed to oil spills are affected in similar ways. Oil coats the fur of sea otters and seals, reducing its insulating effect, and leading to fluctuations in body temperature and hypothermia. Oil can also blind an animal, leaving it defenseless. Animals can be poisoned, and may die from oil entering the lungs or liver. If an oil spill happens, what should we do? I think the most common is cleanup and recovery. Cleanup and recovery from an oil spill is difficult, and depends upon many factors, including the type of oil spilled, the temperature of the water, which will affecting evaporation, and biodegradation process, and the types of shorelines and beaches involved. The spills may take weeks, months, or even years to clean up, depend on what is the amount of oil. Several methods can be used to clean up and recovery if oil pollution occurs, such as building a barrier or berms, to block the oil from entering an aquatic environment, for example, to the river. Sorbents also can be used to absorb the oil. Normally these sorbents can absorb oil in the surface water. We also can place booms in the affected area. These booms can help to keep the oil not spreading to other areas. If the oil reaches the beach or land area, we can use a vacuum to clean up. Or debris removal. Normally this method applies to a bigger scale size area. Some areas might not be suitable to vacuum, so the flushing method is used. Normally areas with a rocky shore, or breakwater, the flushing method is used. The dispersant technique is used at offshore. When the oil spill happens, before the oil spreads to other places, the dispersant technique is used. Normally, this technique uses a chemical to break down or neutralize the oil. The last method is manual cleaning or removal. Normally this method involves a lot of people as volunteers. That's all for this chapter. Thank you. Have a nice day.